All right, so today we're going to talk about division. Now, it should hopefully be kind of a review because you did this division last year in Algebra 2. I know you did polynomial division. There's long and there is synthetic division. All right, so we're going to review over long division and synthetic division. And we're going to briefly talk about kind of some new pre-cal stuff that it applies to. But really, the application part is going to be more tomorrow and Wednesday for these divisions. So right now, we're just going to be dividing. Now, long division is a process that's going to divide two polynomials of any form. This process is longer, but it works for any divisor. So any kind of problem you could do long division for. There's no stipulations for long division. Now over here, I did put the steps for long division. I typed them out and I tried to type out some examples and stuff for you. So if you go back and look at your notes, you kind of have more of a process. But we're going to just jump straight into an example. All right, but the steps that I'm doing down here are the steps that I typed out for you. But you can read. I don't have to read the chart for you. All right, so first thing we're going to do is we're going to draw a division sign and write kind of small. And we're going to write 2x cubed minus 13x squared plus 26x minus 24 all underneath my division sign. And on the outside, I'm going to put x minus 4. So that's called your divisor, what you're dividing by. That's going to go on the outside. And we are going to long divide, which you did do back in elementary grade school, maybe, is when you did long division with numbers. Do you remember doing that? Where you did 18 divided by 180, let's do that, divided by 9, right? And you would say, okay, how many times does 9 go into 1? It doesn't. 9 going to 18 is 2, and then you would do 2 times 9, right? And you would subtract it. And 0. And so 180 divided by 9 is 20. Y'all remember doing that? And if it didn't divide, you'd have a remainder. Wait, what gave you the most trouble? This? Yeah. Yeah. Well, now we're going to do it with letters, so it can only get better, right? So that whole process, it's kind of cool that you can use that exact same process with the letters. All right, so we are only going to look at the first terms. All right, so the 2x cubed and the x. And you're going to ask yourself, what times x is going to give me 2x cubed? 2x squared. And I'm going to write that up top because this is where my answer is going to go. Now, some of you are really good at doing the multiplying in your head. Personally, I like to write that off to the side. So off to the side, I'm going to write 2x squared, and I'm going to times it by my divisor. All right, so just like when you're doing the long division with numbers and you take that number that you put on top and you times it by this outside number, we're going to do the same thing. We're going to take 2x squared and we're going to times it by x minus 4. And so we're going to distribute and we get 2x cubed minus 8x squared. And then just like the process with the regular long division, with polynomial long division, we want to take this guy and we are going to subtract it. When you're subtracting, all of your signs change. So if you are really bad at doing stuff in your head, it might be a good idea to write everything with a different sign off to the side so you don't forget. Because when you subtract, all of the signs are going to change. And so this guy right here, the negative 2x cubed plus 8x squared, that's going to go underneath and we're going to line up like terms. So negative 2x cubed plus 8x squared. Some of you are really good at mental math and you can do 2x squared times x minus 4 and change in the signs and write it right here and not do any of the work off to the right, which is fine. Just don't make any mistakes. Because if you're doing mental math, I can't give you partial credit. Yeah.
Why did it
So when you subtract, you have to switch all the signs. So that's why over here, sometimes I even like to write all the signs switched over here so I don't forget to switch it when I'm writing it down. All right, 2 minus 2 is 0, and if you did this correctly, those first terms should end up canceling. Negative 13x squared plus 8x squared is going to be negative 5x squared. And I'm going to drop down all this other stuff, plus 26x minus 24. And we're going to do it all over again. What times x is going to give you negative 5x squared? 5x. Negative 5x. And then off to the right here, I'm going to multiply negative 5x times x minus 4. Yeah. Negative 5x squared plus 20x. And because we need to subtract this polynomial, all of the signs are going to switch. So what I'm going to write underneath is positive 5x squared minus 20x. Yep, so if you did it right, that first term should cancel, which it does. Negative 5 plus 5 is 0. 26x minus 20 is 6x, and I'm going to drop down the minus 24, and we're going to do it again, and we just keep doing this process over and over again. So what times x is going to give me? 6x. 6. And when you get down to just a number, that's kind of your indicator that you're done. All right, so this is my last round. So I'm going to go 6 times x minus 4. And I'm going to go 6x minus 24. Switch the signs. So negative 6x plus 24. And line it up. Which to the front, guys, yay, they cancel. And negative 24 plus 24 also cancels. And it's going to give me 0. What is 0 called in this instance? Remainder. Remainder. So my remainder is 0. I don't have to write it since the remainder is nothing. And so I just have to write this as my answer. The top guy here, the 2x squared minus 5x plus 6. That is my answer to this problem. So 2x squared minus 5x plus 6 is what is left after you divide x minus 4 from that polynomial. Okay, let's do another one. All right, so I'm going to do my division sign. 4x to the 4th minus x squared minus 18x plus 8. And on the outside, x squared plus 2x plus 3. All right, so these guys are a little bit longer. Now, I'm going to come back here, but I want to mention one more time. On this problem, all this work I did over here to the right, you don't have to write now. All right, I'm not going to grade that ever. I at least recommend writing that multiplying step down. A lot of people can do the switching of the signs in their head and then just write that down over here. But if you're really worried about messing up and forgetting about a switch sign, you can write it down. On this next example, I'm going to skip that switching the sign step, and I'm going to just switch signs when I line up my like terms. So I can show you what that looks like. But I really do recommend that everybody writes down the multiplying stuff off to the right, unless you're really good at doing math in your head. Alrighty. So what times x squared is going to give me 4x4? 4x squared. 4x squared. All right, off to the side here, I'm going to write 4x squared, and I'm going to times it by x squared plus 2x plus 3. Which is going to give me 4x4 plus 8x cubed plus 12x squared. All All right, so I know when I switch all the signs, all of those positive guys, they're all going to be negative. So when I line it up, it's going to all be negative. Does that make sense? All right, but what's the problem here when I try to line this up? What am I missing?
X's. They don't line up.
I'm missing an x cubed, which is fine. Just when you line it up, we're going to make note that the x cubed isn't there. It's like having a 0x cubed. So I'm going to go minus 4x4 minus 8x cubed minus 12x squared. So I'm just going to kind of squeeze in that 8x cubed and just know I'm not combining that with anything because there's no other like terms. Since I did this correctly, the 4x4s, they do end up canceling. So yay, I'm doing it right. There is nothing to combine with the x cubed.
Wait, why did they become negative?
Because you have to switch it. When you are doing the long division, you multiply and then subtract. When you subtract, all the signs switch. So negative 8x cubed.
Minus 13.
Good, minus 13x squared. Drop down, minus 18x plus 8. All right, now we're going to do it again. So what times x squared is going to give you negative 8x cubed? Negative 8x. So over here to the side, I'm going to do negative 8x times x squared plus 2x plus 3. And when I multiply, I get negative 8x cubed minus 16x squared minus 24x.
Yep.
All right, and then we are going to flip the signs. If you want to write it with the signs flipped, you can, but I'm just going to line it up with all the signs flipped. So instead of a negative 8x cubed, it's going to be positive 8x cubed and plus 16x squared and plus 24x. So all my signs are going to switch. Front term should end up canceling, which they do, negative 8 plus 8. Negative 13x squared plus 16x squared is going to be 3x squared. Negative 18x plus 24x is going to be 6x. And then I'm going to drop down the plus 8. All right, and we're going to do it again. What times x squared is going to give me 3x squared? 3. And so because now I'm down to my regular old number, I know this is my last round. All right, so this is it. So I'm going to go 3 times x squared plus 2x plus 3. So 3x squared plus 6x plus 9. All right, so distribute the 3. And we got to switch all the signs. And we're going to line it up. So negative 3x squared minus 6x minus 9. The front guy should end up canceling. Yes.
On the green part, how did we get 13?
Is 13?
It was 12.
Oh, negative 1. The understood 1 here. And then negative 12 make the negative 13. Okay, so my front term cancels. My x's also happen to cancel. It does not always work that way. Sometimes you have x in your remainder. All right, so if you get x in your remainder, and I think that happens maybe on number 2 of your homework, but if you get x in your remainder, that is okay. But in this case, it cancels, which is also fine. 8 minus 9 is negative 1. So right now, I've got negative 1 as my remainder. So let's talk about how to write this answer. So back in grade school or elementary or whatever, when you did this with regular numbers, there was a couple different ways you could write it. You could literally just write remainder negative 1. Right? There was a way that you wrote it as a fraction. Do you remember how to write it as a fraction? So we're going to start off with the answer, the 4x squared minus 8x plus 3 plus, what goes on top? Negative 1. What goes on bottom? Good. X squared plus 2x plus 3. Whatever you're dividing by goes on top. So this is probably the way that you're going to see that I wrote the answer on my key and stuff like that, because that's how you see it often on the multiple choice test. They kind of get away from just saying like R is this, because that's too easy. And we got to write it as a fraction. So remainder over divisor. So whatever your remainder is, whether it has x or whatever in it, whatever your remainder is goes up top. Whatever you are dividing by goes on bottom. You are always adding the fraction. All right, so it's always plus remainder over divisor. So don't overcomplicate it. It's not supposed to be complicated. It's just the way to write it.
And is that the format that homework's talking about?
Yeah. So just because it says like what P over Q plus
Yeah.
R over, yeah, something like that. Yeah, that's what it's talking about. Okay. So now we talked about long division, which was the majority of the notes because it's the lengthier of a process. We're going to talk about synthetic now. All right, synthetic division is an alternate process that may be used for problems with a divisor of the form x minus a, or it could be x plus a. I don't know why I'm blurry all of a sudden. It has been blurry the whole time. Yeah, I think it's got something to do with the Wi-Fi. It's like doing weird things. All right, just like long division, I tried to type out a process with steps so you can refer back to that on the notes if you need to. But we're going to just jump straight into these examples. All right, so it says divide the following polynomials using the synthetic division. Synthetic division is so much better because it is so much faster. So if we can use synthetic, we do want to use synthetic. All right, I'm going to draw an upside down division sign. And my divisor is going to go on the outside, but we are going to switch the sign. So it's going to be a positive 4 on the outside.
Negative x plus 4. Or
Just the one number. Yes, good question. Just the one number, so just 4. And then all my coefficients are going to go in the division sign. So the coefficient of the x squared is going to be a 3. The coefficient of the x is negative 13. The coefficient of the number is just 8. All right, so divisor on the outside, switch the sign. Coefficients all on the inside. And we're going to drop the first number down. And we're going to multiply on the outside, add on the inside. So what's 4 times 3? 12. So that's going to go right over there under the 13. And then you're going to add. So what's negative 13 plus 12?
Negative 1.
Negative 1.
Negative 4 goes in.
And then you're going to multiply. Now, we don't multiply the 3. 3 is over. We're done with 3. We're going to do 4 times my new number, negative 1, which is going to give me negative 4. And then we're going to add 8 plus negative 4. 4. And then I do like to box this last number. And the reason why I box that last number is because it's called the what? The remainder. Very good. All right, now to write my answer. I took this polynomial, 3x squared minus 13x plus 8, and I divided out an x minus 4. So I took x away from it. So since my original answer started with an x squared, what is my original problem started with an x squared. What is my answer going to start with?
X squared.
X, because I took an x away. I divided an x out, so we're going to start with 3x. After x comes your regular number, so 3x minus 1, and then your remainder, which we're always going to do a plus sign, 4 over, what's my divisor? X minus 4. All right, let's try another one. So I'm going to do a little division sign. What number goes on the outside?
2.
A 2, because it's x minus 2, so I'm going to put a plus 2 on the outside.
So you're going to switch the signs when you put it, right?
Just for this outside one, just the divisor.
Just for that.
Yes. The inside are the coefficients. They're going to stay coefficients. Essentially what you're doing to the divisor, the reason why it switches sign is because it's in a factor. You're setting it equal to 0. So that's why it's switching signs. All right, so what is my coefficient of the x4 term?
2.
2. What about the x cubed?
-9.
X cubed.
Oh, 0.
0, because x cubed isn't there. So we do have to fill in a 0 spot because x cubed is missing. Then x squared is going to be -9. And then x -3. And then 10. So go in descending order. Go, okay, x4, x3, x2, x, and then number. So go in descending order in your brains when you're doing your coefficients. And now we're going to start the whole process. All right, so we're going to drop the first number down. So drop the 2 down. What goes underneath the 0? 4. All right, and then 0 plus 4 is?
4.
What goes underneath the 9? -9.
8.
-9 plus 8?
-1.
What goes underneath the -3?
-2.
-3 plus -2?
-5.
And what goes underneath the -10?
-10.
I'm sorry, the 10, yeah. My brain got ahead of me. 2 times -5 is -10, and so then 10 plus -10 is going to be 0, so my remainder here is 0. If your remainder is 0, do you have to write it?
No.
No. All right, so since your remainder is 0, those are the nice ones. We don't have that fraction. All right, my original problem started with an x4, and I divided an x away. So what's my answer going to start with? X cubed. So 2x cubed plus
4x
4x,
-1.
4x, 4x,
Squared.
yeah, minus 1,
X
and then minus,
5.
yep. So then your answer will go in descending order as well, 3, 2, 1, and then number. If you run out of spots where like you're ending on x instead of ending on a number, that's probably a good indicator that you missed a 0 term. So it should always work out where you have enough coefficients to write your next polynomial. Make sense? Okay. All right, we have 2 kind of theorems that division gives us. All right, the first one is the remainder theorem. All right, if f of x is divided by x minus c, then the remainder is the same thing as f of c. So it's kind of just a cool little theorem that helps you solve problems if you don't have a calculator. So let's look at it 33. It says use the remainder theorem to evaluate f of x equals 4x squared minus 10x minus 21 when x is 5. So if you came across this question, what would you do? If you wanted to evaluate when x is 5, what would you do?
Plug in and out.
Yeah, you'd plug in chug, right? You'd go 4 times 5 squared minus 10 times 5 minus 21, and you would work all of that out, and you would get 29, and you'd say, all right, 29 is my answer, which is totally fine. And I'm going to be honest, that's most of the time how I do it because I forget about the remainder theorem. I forget that there's this really cool theorem that we have that makes things a little bit easier. So let's use the remainder theorem, and let me show you how your answer is still 29. So if I take my guy, and I'm going to divide 5. Now, regular 5, we're not switching the signs because it's not in a factor. It's just x equals 5. So 5 is going to just stay 5 here. What are my coefficients going to be? 4,
-10,
-10,
-21.
-21. All right, now I'm going to do the synthetic division. So I'm going to drop the 4 down. 5 times 4 is?
20.
-10 plus 20 is?
-10.
Just 10, right? Okay.
Yeah, sorry.
5 times 10?
50.
And then -21 plus 50? 29. Look at that. And your remainder is going to give you the same value.
I mean, I feel like it doesn't speak anything.
It's just one of those cool tricks. Like, are you ever going to absolutely need to know the remainder theorem? No, but it's just kind of a fun little trick. All right. Now, the factor theorem, that one you will use. If f of k equals 0, which remember from the remainder theorem means the remainder is 0, then x minus k is a factor. All right, and if x minus k is a factor, then f of k equals 0. And what is another name for a 0? X-intercept, which means that it's an x-intercept. Or a root or a solution. So if your remainder, if your remainder is 0, that means that it is divided evenly. It's a factor. That's where one of your x-intercepts are. And we're going to be using that guy tomorrow and Wednesday. So on this last question, it says, is x plus 3 a factor of this guy, and explain. So to check to see if it's a factor, I'm going to check to see if it divides evenly. So I'm going to do my synthetic division here. What number goes on the outside? -3. All right, it's in the factor. We got to switch the sign. What about my coefficients?
3, 4,
Good. 3, 4, -18, -3. And we are going to drop the first number 3. All right, -3 times 3 is -9. 4 plus -9. -3 times -5.
Positive 15.
-18 plus 15.
-3.
-3 times -3.
Positive 9.
And -3 plus 9.
6.
6. So is this a remainder?
Yeah, but it means
Or, sorry, is this a factor?
no.
No. No, because the remainder is not 0. So if it's anything besides 0, it's not a factor. If it's 0, it means it's a factor. All right, questions?
So on, I'm looking at the homework right now, on number 10, it's like the exponents go like 20, 10, and then 1 and then 1.
Where are we? Finding, wait, dividing.
You just do long division of that and then skip a bunch? Because there's no way you can do synthetic.
Import new. Pre-cal.
Qualifies there.
Doo-doo. Oh, yeah, this one?
Yes.
So on this one, because I don't want to do synthetic and have to skip 9 to all the way to 1, right? So instead of using synthetic to find the remainder, instead I'm going to plug in 1 using the remainder theorem. Yep.
Okay. And then would you use what we used on
The factor theorem.
factor theory on number 9?
Yeah, so this one you would do synthetic, and so 2 would go on the outside. And then this one you'd have k's, but just work through it with the k's, and it's actually kind of cool how it happens. But your coefficients are 1, -k, k, and 2. And so just kind of leave k in there through your process. And well, what do you know your remainder has to be? 0. No, you have to come up with a k value so it is a factor. So you're coming up with k to make it a factor. So you're gonna do synthetic all the way through there. You're gonna get some expression that has k in it, set it equal to 0, and solve.
How do we know if we use synthetic or x minus 2, x plus
Mm-hmm.
x minus
So like on number 1, could you use synthetic? Yes, because x minus 2. But what about on number 2? No, because it's got the, yeah. Well, the x squared, the exponent. It's got to be x plus a number or x minus a number if you're going to use synthetic. Otherwise, you have to do long division. What's up?
So let's say for number 2, could I go 2x cubed plus 0x squared and then minus
Yes. Oh, wait, no, but it's not 0. They just wrote this out of order.
Oh, it's out of order. Well, let's
Yep.
say it wasn't there.
If it wasn't, yes, you could fill in the plus 0 if you wanted. But this one is just out of order because they were mean. What a dirty trick to play. Which other one is missing a term? This one, number 8's missing a term. So David, on number 8, like if you did your guy here and you did 3x cubed plus 0x squared plus 4x plus 11. So you had a spot for each one, you could.
Okay, goodness.